Okay, so this is the first technique we're going to look at, X-ray crystallography. It's a technique that allows you to go directly from some experimental data, shown here, directly to a 3D picture of the sample of interest. So we're going to be coming back to this picture many times. This is the electromagnetic spectrum, showing light of various different wavelengths. And of course, here is the high energy, and here is the low energy parts of the electromagnetic spectrum. And all these different wavelengths or energies of light are useful in different ways when we're interrogating a sample to figure out its molecular structure. So we're first going to be starting here, looking at the X-ray part of the spectrum, where we're going to be using the technique of X-ray crystallography. So the reason it's called X-ray crystallography is because this technique requires your sample to be in a high quality crystal. So there's a crystal, we've mounted it there, and we're shining X-rays through the crystal. And as the X-rays pass through the crystal, they interact with the atoms in the crystal, and the X-rays get sent in different directions or diffracted. And in areas where there's constructive interference, you get a spot when the X-ray arrives at this detector. And so you get this characteristic diffraction pattern, which is characteristic for the crystal of our sample. So once you have the diffraction pattern, we then use computational methods that turn that diffraction pattern directly into this 3D picture of the molecule that shows you the positions of all the atoms in the sample. And if I were to draw it as a 2D structure, this is the molecule that corresponds to this 3D picture. So finally, a little bit of context. There's essentially two principal methods for determining molecular structure. There's methods like X-ray crystallography called direct methods, because they take you directly from experimental data to an actual picture of your molecule. Then there's also a bunch of different spectroscopic methods that we're going to look at in more detail later that are more indirect. But in all cases, the idea is that we're using energy to interrogate the structure in some way, and we're going to use the readout to give us information about the structure of the molecule. So now you've seen X-ray crystallography, and then a little bit later on we're going to look at all the various different spectroscopic methods.